Hey guys, welcome back to your algebra lesson. We are finally in our statistics unit, and this should be on page 3 of your packet. So we have a bunch of vocabulary terms that we have to understand. Most of them are typed up, and then there's a few at the bottom that we are going to add to. So first, it says in a group of numbers, so I'm going to just give you a list of numbers, and here they are. So we've got a list, and I put these numbers in order from smallest to greatest. That is important. Whenever you have a list of numbers in statistics, in essentially what we're dealing with, you want to put them in order so that you can find everything accordingly. So we've got 1, 2, 3, 5, 7, 7, 8, 10. I just made these numbers up. So we're going to figure out a few things from this list of numbers. The first is the mean. Now, the mean is also known as the average, and most of you are very familiar of how to find your average in a class. So you would add up all your test scores, for instance, and your homework and everything like that, everything that you've been graded on. You add them up, you figure out what is the sum, you divide that by how many things are in the grade book, and that should give you your average. So we're going to do the same thing here. We are going to add 1 plus 2 plus 3 plus 5 plus 7 plus 7 plus 8 and 10 together. And when we add those all together, we should get 43. And when we divide 43 by the number of items in this group, and there are 8 total numbers, we will figure out our average. Now the average, instead of writing out the word average or mean, we are going to use this symbol. It's X with a line above, and when we divide 43 divided by 8, we get 5.375. So that is our mean. Again, to figure that out, add all your numbers together and divide by the number of items or numbers that you have. Okay, the next item is the median. The median is the middle score, and to figure out what that middle score is will vary depending on if you have an odd number of scores or an even number of scores. So we will write down an odd number of scores to figure that out. So again, I'm just making these numbers up, but you always want to write them in numerical order, so smallest to largest. So we'll just do 3, 6, 10, 14, 15, and that is going to be 1, 2, 3, 4, 5 numbers. That's odd. And to figure out the median, or the middle, all you have to do is look at the middle term. So in this scenario, 10 would be the median. Now, if you look at the group of numbers that we wrote in the beginning, it's an even amount, so there are going to be 2 middle numbers, and then you have to figure out the average between those two. So you have to figure out what's the middle number between the two middles. So if you look up above, right, so since you have 8 numbers total, okay, there's going to be 2 numbers in the middle. And I'm going to circle those 2 numbers so that you can see that there are exactly 3 to the left and 3 to the right. That's how we know we are exactly in the middle. And to figure out, this one's a little easier. The number that's between 5 and 7 is going to be your median, and that number is going to be 6. Now, sometimes they're not that easy, so I'll show you how to do that mathematically. It's just like finding the average. You will take those 2 numbers that are in the middle, you will add them together, and you will divide by 2 because there are 2 numbers. Now, 7 plus 5, that gives you 12, divided by 2 is 6. So the math matches the logic. But you can just do the logic way because that's really easy. 6 is definitely in between 5 and 7. Okay, so we've got mean, we've got median. Now we move on to mode. Mode is the number that appears most often. So sometimes there is a mode, sometimes there's not. Sometimes there's more than one mode, and we'll get into that in the second vocab term underneath. So in our first list of numbers, the mode, the number that appears most often, is going to be 7. Because 7 appears twice and none of the other numbers repeat. Now in bimodal, that happens if there are two equally frequent numbers that appear most often. So I'll give you an example again. I'm just going to make this up on the fly. So if we have, for instance, 1, 2, 2, 4, 5, 5, right? Then bimodal, the two modes, the two numbers that equally appear most often in this scenario would be 2 and 5 because they both appear twice. Now, if you have no mode, it means that none of the numbers repeat, they all happen at the same amount. And that could happen as well. Now on to the range. The range is pretty much how far your numbers are going to span. So you have to figure out from the highest number down to the lowest, what's the difference between those. So if you take your highest number, which in our main example at the top in pink, the highest number would be 10. So if we take 10 and we subtract the lowest number, which in our example is 1, then our range is going to be 9. Okay, so we did all those. On to measures of central tendency. So measures of central tendency are the three main M's. So you got mean, median, and mode. And if you watch that really corny video that I posted, the mean, median, mode, it's like a song, it gets really stuck in your head. Essentially, if a question says, find the measures of central tendency, then you have to understand that you're finding the mean, which is the average, right? Adding all the numbers together, dividing by the amount of numbers that are in the group, the median, otherwise known as the middle. And one way to remember that is when you're driving down the road, right? The median is that middle divider part, like on a highway. So median, middle. And then mode is what we just talked about. That is what occurs most. Okay? So mean, your average, median, the middle, mode, most. The next thing that is new is outlier. Now, outlier, if you think out, it's like out of the main spread of data. So it's a value that's either much less or much more than the rest of the data. So in the list of numbers that I gave you, there wasn't an outlier, but I'll make one up now. So if I said, here's your list of numbers, 1, 2, 5, and then we say like 36, right? Then 36 is a number that is just too high. It doesn't quite belong with the rest of the data, and that would be what we would call an outlier. Now, when we get into more specifics, there is a mathematical test that we'll learn, but for now, we're just going to use logic, and if a number is either too low or too high compared to the rest of the numbers in the list, we're going to call it an outlier. Okay. At the bottom of the page, we are going to add 4 definitions, and those 4 vocabulary words are quantitative data, qualitative data, univariate data, and bivariate data. So we have to understand these 4 vocabulary terms before we can do our bell ringer today. So we'll start with quantitative data. So quantitative data should make you think of quantity, which deals with numbers. So this type of data involves numbers, so anything that can be represented as a number, for example, ages, test scores, amount of money, things like that, your basic statistic items. Whereas qualitative data, you should think of, here's how I think of it, quality. So it's not numbers, it's data that involves descriptions and opinions, like your favorite ice cream or your favorite animal or, you know, eye color, things like that. Now we'll compare univariate data to bivariate data. So univariate, if you see the prefix uni, you're going to think 1, versus bi, you're going to think 2. So univariate data is going to be data involving one variable. So your examples might be just test scores, just the shoe size, and only the height. As opposed to bivariate, where you're talking about comparing two different things like eye color and intelligence, pet size and family size, height and shoe size, things like that. And one way to remember with the bivariate, the prefix bi, so you'll see like bicycle. Bicycle, there are 2 wheels, things like that. So whatever helps you remember, you'll be better off. And now would be a good time to pause the video if you don't have all of these vocabulary words written down before we flip the page and move on to page 4 of our packet. Okay, here's page 4. So given the data, we have a list of numbers, 9, 2, 6, 2, 1, 4. Before we figure out the median, the mean, the mode, all that stuff, what you want to do first is rewrite the data in ascending order from lowest to highest. So you should have 1, 2, 2, 4, 6, and 9. And once these numbers are in order, we can find the median. So there are 6 numbers in this list, and because there are 6 numbers, and that's an even number, there are going to be 2 middle terms. So you should circle the 2 middle terms now, and if you notice, those 2 middle terms should be 2 and 4, because you have 2 terms to the left and 2 terms to the right, so that you know you're exactly in the middle. And the median, the number that is between 2 and 4, is going to be 3. And if you're not sure how I figured that out with logic, what you could do is you could find the average between those 2 numbers. And how to find the average is you add up the numbers you're focusing on, divide by the amount of numbers that you have. So 2 plus 4 is 6. 6 divided by 2 is also 3. So we can show that the math and the logic go hand in hand. Okay, on to the mean. We're finding the mean, also known as the average. And if you remember from the front, the symbol is the X with a line above it. So to figure out the mean, you are going to add all of the numbers in our list together, and then you are going to divide by 6 because there are 6 numbers in our list. When we add all these numbers together, we will end up with 24, and 24 divided by 6 is going to give us our mean, which is 4. Okay, on to the mode. The mode, remember, is the number that occurs the most. So the only number that is repeating is 2. So 2 is going to be our mode. The range is the span of numbers. So your highest number, which in this scenario is 9, and then that has to subtract your lowest number, which in this scenario is 1. So our range is going to be 8. Next part says the ages and the number of children at Room to Grow daycare are given in the frequency table below. Now, the word frequency is how often something happens. So, in order to understand this table, ages, so the first one says ages, and then we've got 1. So there is a 1-year-old, and then it says frequency 3. So that means that there are 3 1-year-olds. Ages 2, frequency 1, means that there is 1 2-year-old. Ages 3, frequency 5, means that there are 5 3-year-olds. Age 4, frequency 0, means that there are no 4-year-olds. And age 5, frequency 1, means that there is 1 5-year-old. So, cumulative frequency is something where you add all of the previous frequencies together. And one way kids remember this is it's like a snowball effect. So you're adding on from the previous thing, and if you think of a snowball and you roll that little ball and you keep rolling it in the snow, it's going to accumulate and get bigger and bigger and bigger, and that's what's going to happen here. So cumulative frequency, you start with the first frequency number that you see in the list, and that's going to be 3, okay? And then you start to add in what you have. So you're going to add in 1 to that frequency, so now there are 4 kids that we know of that are either age 2 or younger. And then if we keep on adding, we have 5 kids that are age 3 that we need to add to the list. So if we add 5 to our previous number, we should be at 9. So that's telling us that there are 9 kids that are either age 3 or younger. Now, when we get to age 4 and there are 0 kids, adding 0 to our cumulative frequency just keeps us at 9. And then in the final part, at age 5, there is 1 kid age 5, so that 1, so there's 1 kid age 5, that 1 has to also add. I'm running out of room, and there should be 10 kids, and that number is our total. So the last number in your cumulative frequency column is always going to tell you the total altogether. So there are 10 kids that are either age 5 or younger at this daycare. So question 1 below says find the mean age. So there's a couple ways that you can do it. You could either list out all of these ages, so since there are 3 1-year-olds, you could say 1 plus 1 plus 1. There is 1 2-year-old, so you would add in 2. There is 5 3-year-olds, so you'd have to add in 3, but you'd have to do it 5 times, etc. Or you can kind of take a shortcut and you could do it like, since there is 3 students or kids who are age 1, you could take that 3, multiply it with 1, plus there is 1 kid that is of age 2, so that's just plus 2, plus there are 5 3-year-olds, so you could do 5 times 3. You wouldn't have to add in the 4-year-old because there is no 4-year-old, and then plus 1 5-year-old, all divided by, there are 10 kids total. So if you add those numerators together, you should end up with the number 25. So again, the mean, that symbol is X with a line above it. 25 divided by 10 is going to give you your average of 2.5. which means that the average age of a kid at this daycare is 2.5. Now for the next part, we can either answer just yes or no. So for 2, 3, 4, and 5, these are yes or no questions. Is the data qualitative? So remember, qualitative is quality. You're dealing with descriptive things, you're dealing with opinions. It can't be using any numbers. So that's going to be a no, because this data is quantitative. Quantitative means that it has to deal with numbers. Since we're talking about ages of kids, it has to be numbers. Now, one thing to consider is data can never be both qualitative and quantitative. It's either one or the other. So if it is quantitative, it can't be qualitative, and vice versa. Same thing with univariate and bivariate. Data could never be both univariate and bivariate. It has to be one or the other. So we have to figure out, is this data univariate or bivariate? And because we're only talking about ages and nothing else, that's one variable, and one variable means that it is univariate. So yes to univariate, which means that it cannot be bivariate. And the reason it can't be bivariate is because bivariate deals with two variables. So in order for this to be bivariate, it would have to be dealing with ages and something else. Number 6 says calculate the cumulative frequency. So we did that, as we did it in our list already. Number 7, which age represents the median? Okay, so now we are going to write all the ages out in order. Again, always lowest to highest. So we have age 1 needs to be written 3 times. So 1, 1, 1. Age 2 is written once. Age 3, we have to write 5 3s here. Age 4, we're not going to write a 4 because there is no 4. And age 5 only needs to be written once. So, since there are 10 total numbers, that's an even number, there's going to be 2 middle terms. We are going to circle those 2 middle terms. And those 2 middle terms should be 3 and 3. Because if you count, you have 1, 2, 3. There are 4 terms to the left and 4 terms to the right. And if you circle 2 of the same number, then that is your median. So your median here is going to be 3. Is there an outlier? Remember, outlier is something that doesn't quite belong. It's either too low or too high, and there is no outlier. There's no number that's too low or too high compared to the rest of the data. And then number 10, what age would you consider to be an outlier? Well, it's always safe to consider an outlier that's very far out there. So really high or really low. We can't go too low because we can't go into negatives for age, so just pick any large number out there. Let's go with, 60, right? 60 compared to 1, 2, 3, and 5 is crazy, so 60 would definitely be an outlier. But again, you can pick any number that's really large. And that's going to conclude our notes for today.